Hey guys, we are going to take a look at Chapter 8, Lesson 2 today, volume of cones. You can follow along starting on page 598. Page 598. Okay, so a cone, textbook definition of a cone, is a three-dimensional figure with one circular base connected by a curved surface to a single vertex. Last week we were calculating volume of cylinders. Cylinders have two circular bases. So that's really the key difference here. So my question to you is, how can we derive, meaning how can we come up with the formula for the volume of a cone by using what we know about the formula for the volume of a cylinder? So these are two really rough drawings. Just as a review, so here are two circular bases of our cylinder connected by a curved surface. We know that the area of one of the bases, which is pi r squared, times the height is going to give us the volume. So volume is equal to pi r squared times height. So now I want to know, well, what's the formula for the volume of a cone going to be? So here's something I want you to think about. If I were to, let's say, fill a cone up with water with the same radius and height as a corresponding cylinder, how many cones would fit into that cylinder? Okay, normally I would have you guys actually do this. I have geometric solids. I would have you fill up the cylinder with cones and count how many times you could actually fill it up. Well, we can't do that, but I do have a YouTube video that I'm going to show you here in just a second. A common guess is 2. So let's see if that's right, if that's a good guess. So let me go ahead and this is a really quick video here that's going to show you pretty much exactly what we were going to do. Two geometric solids, one is a cone, one is a cylinder. They have the same height and the same radius. The base has the same radius. So there's one, not quite halfway. Here is 2. So 2 is not going to work. Our original guess was 2. 2 is not going to check out. Let's see if 3 will actually work. And it does. Okay, so let's see here. Let me pause this and let's go back to the notes. Since we know basically that 3 cones of same radius and height fit into a corresponding cylinder, can't we then just take our formula that we were using last week, which is the area of the circular base, pi r squared, times the height, and divide it by 3? It stands to reason. 3 cones with same height and radius fit into one cylinder with same height and radius. So you can take that same formula and just divide it by 3. So it's kind of nice. You don't actually really have to learn any new structure here. It's just one slight modification. Okay, another way you're going to see this written is dividing by 3 is the same thing as multiplying by 1/3. So 1/3 pi r squared times height. These are interchangeable. This is really the one you're going to see me use, but they both work. So just be consistent here. Height, I have in orange, and radius, I have in pink. Okay, so the homework, if you did 8-1 and it was doable for you, 8-2 should be very doable. It's really more the same with one extra step, dividing by 3. So you're going to see figures where they give you information. Sometimes they're going to give you radius, sometimes they're going to give you diameter. So if you take a look at A and B, I'm actually going to have you guys do B, because for A they're giving you radius, but for B they're giving you diameter, and I need for you to remember that we don't want diameter, we don't want the distance all the way across, we want the distance halfway across going through the center of the base. So we do that by dividing by 2. So diameter of 24 divided by 2 tells us the radius is 12. So you're going to go ahead and just plug everything in here. Pi times 12 squared times the height, which is 26. Don't forget to divide by 3. The most common mistake in this lesson is people just forget. They're so used to this formula from 8-1 they forget to divide by 3. So I'm going to go ahead and show this on the document camera. Model it for you guys. Okay, so by the way, if you don't have a pi button, just use 3.14. That's fine, as an approximation. Okay, so pi, or 3.14, and you don't even have to hit times, it'll work if you don't. 12. X squared squares my radius of 12. I'm going to multiply by the height, which is 26. Okay, and then at the very end, I'm going to divide everything by 3. And I get, let's see here, 3,920.7. And let me just check to make sure that's correct. And it is 3,920.7. Volume is approximately, remember, because pi is irrational, you can only estimate it. 3,920.7. And something I was not good about in the last video is including the measurements. Millimeters, go ahead and include the unit of measurement, and that's cubed. Okay? Sometimes people think, oh, does that mean now I have to raise 3090.7 to the third power? No, this is just basically it's part of the answer. It's like a label, so the reader knows, hey, this is 3-dimensional, right? It's not 2-dimensional, it's not area, it's volume, it's 3-dimensional. So here is our whole entire final answer. Okay, let's move on a little bit here. You're going to get some word problems. It's more of the same. Sometimes they're going to give you radius. Sometimes they're going to give you diameter. If they give you diameter, make sure you got to cut it in half. Otherwise, it's pretty much the same. They're just not giving you an image. If it helps, draw it out. They're going to give you some composite solids, just like last time. So in this case, you're going to be figuring out the volume of the cylinder, and you're going to be adding it to the volume of the cone. So volume of the cylinder, here you go. Our diameter is 8, which means halfway across our radius is 4, times our height is also 4. So the volume is about 201.1. Now let's go ahead and figure out the volume of the cone. Also has a diameter of 4, right? It turns out that one of the two circular bases of the cylinder is the circular base of the cone, so it's got to be the same. So they're showing 1/3. I would just do divided by 3. So volume is approximately pi. The radius again is 4 squared times the height here they're telling you is 5. Don't forget to divide by 3. All right, so they're going to, let's see if I have another page here. And I do. The volume of the cone is about 83.8. Lastly, you're just going to add those two up to get the final volume. Okay, so this is going to be pretty similar to number 8 in the homework. Let's see here. Example D is going to be very similar to number 7 in the homework, where your composite solid is made up of 2 different sized cones. So I just kind of made a list here. Smaller cone. Both of these cones have a radius of 6. The smaller cone has a height of 5.5. There you go. And the larger cone has a height of 13. So let me plug that in. Smaller cone volume, let's see, pi times 6 squared times 5.5 divided by 3 is going to give me 207.3. Volume is approximately 207.3. We're talking about inches cubed. Okay, volume of the larger cone. Let's see here. Pi times 6 again, still 6. Radius is still 6 squared. This time the height is 13. Divided by 3. And I'm getting 490.1. All right, go ahead and add those two up. 490.1 plus the volume of the smaller cone, 207.3. We're going to get a final answer of 697.4. 697.4 inches cubed. And let me just double check to make sure we got that right. And we did. Okay. So the homework should be pretty doable. Just, don't forget that if they give you diameter, cut it in half. And don't forget to divide by 3. That's probably the number one mistake here. So here's a party hat. They're giving you diameter. Cut it in half. Let's see here. Number 6 has a 4 meter. So here you go. Here's your diameter. Cut it in half. Okay, and then you're just going to plug everything in and divide by 3. Okay. We kind of talked about these ones already. I do want to talk to you guys about 9, 10, and 11. So these ones are a little trickier. So let's see here. 9 says a cylinder has a radius of 5 centimeters and a height of 12. So radius of 5, right, and a height of 12. What would the height of a cone need to be if it has the same volume and radius? Okay, so here's the deal. They both have a radius of 5. So these things, because it says they have the same volume, and we know that 3 of these guys are going to fit into one of these guys if it's the same radius and height. Well, it can't be the same radius and height. Okay, we know that this is the same radius, but it can't be the same height. So basically, if the formula is to divide by 3, if 3 of these fit into one of these, right, you take that same formula and divide by 3, you're kind of working backwards here. You're taking the known height of the cylinder and you're going to multiply by 3 to get whatever the height has to be for the cone. Okay. Moving on to number 10. So this one's, finding the volume of the ice cube is pretty doable. So it tells us the radius is 1.5. I'm going to plug that in and square it. It tells us the height is 2. So those all get multiplied by pi. Of course, you divide by 3 at the end. That is going to give you a volume of about 4.7 cubic inches per ice cube. They tell you that each ice cube, let's see, I'll put it in yellow here. Each ice cube has a weight of about 0.55 of an ounce. Okay? So you're going to take the volume, just like in the tree stump problem in 8.1, you're going to take the volume and you're going to multiply it by the weight of each cubic inch. Okay? So, and then lastly, they're telling you that he's making 10. So how many are 10 going to weigh? So the volume times 0.55 is about 2.6. This is per ice cube. Well, he wants 10 of them, so go ahead and wrap it up at the very end. You're just going to multiply by 10. Okay, 11 is definitely probably the trickiest one here. So it says the volume of a cone with a 30 millimeter radius is 942 cubic millimeters. So here's what's different. They're not asking you to find the volume. They're telling you what the volume is. They're also telling you what the radius is. Well, what's the question? What is the height of the cone? So you're going to have to rely on your algebra skills here. So I went ahead and I plugged in what our volume is. So instead of V, I'm going to plug in 9,420. And I'm going to plug in the radius, which is 30. I'm going to just call height H. That's what we're solving for. And all of this gets divided by 3. So we need to undo everything that's been done to H. I'm actually going to put this on a separate page. Okay, so here we go. I'm going to bold my H. I want to get it by itself. I'm going to draw my little boundary line so I can move easily from the left side of the equation to the right side. So I want to undo everything that's been done to this H. Right now, all this stuff up top is being divided by 3. Okay, so if you're going to do reverse PEMDAS, and that's what's happening, right? Using inverse operations is reverse PEMDAS. So adding and subtracting, well, there's no addition or subtraction going on here. So you're going to go to multiply, divide. So let's see here. I'm gonna in order to even to get to this stuff, I have to get rid of this divided by 3 first. Okay, so I'm going to do the opposite of divided by 3, and I'm going to multiply both sides by 3. Okay, so 9,420. 9,420 times 3 is going to give me 28,260. 28,000, whoops, I don't know what's happening. 28,260 is equal to, I still have my pi, I still have my 30 squared, and my h. Okay, so now I have a lot of multiplication to undo. And actually, before I do that, I'm going to go ahead, I'm just going to simplify. Well, 30 squared, if 3 squared is 9, then 30 squared is 900. So I'm going to simplify that, bring pi back down, bring my h back down, and bring down 28,260. So at this point, essentially, this is a bunch of multiplication. Pi times 900 times h. I need to undo times pi and times 900. A couple of different ways you can do it. You can go ahead and you can approximate what this is. That might be maybe the most intuitive thing for you guys at this point. So 900 pi is 2,827. 2,827. 0.4 times h. Again, I'm going to bold that. I want it to stand out. All this is still equal to 28,260. So now I want to undo 2,827.4 times h by dividing. 2,827.4, and then go ahead and divide on this side as well. 2,827.4. This cancels out. What you're left with on the right is just h. And I'm going to let you guys wrap it up from here. An alternative method from this point is you could just divide both sides by 900 pi. That's okay too. So let me just show that. 28,260 is equal to, you can call it pi 900. You'll actually, the correct way is to say 900 pi, but that's okay. H. So you could just as easily divide by 900 pi or pi 900. If this is confusing to you, simplify the two and then go ahead and divide. Okay, that's pretty much it for today. Spiral review, I do want to just show you one thing quickly. So this is review from 7th grade. These are find the volume of each pyramid. So here's the deal. I want you to notice something. 30, 32, and 33 all have rectangular bases. They all have rectangular bases. So the formula should be pretty intuitive. You're going to find the area of the base, length times width. You're going to multiply by the height. Just treat this just like a cone. 3 of these guys are going to fit into a rectangular prism, so it gets divided by 3. So basically the area of the base times the height divided by 3. This is going to work for 30, 32, and 33. 31 is different. Take a look at the base. The base is not rectangular. The base is a triangle. So I kind of drew it out here. If you can imagine I don't think I even need these. Well, you know what? I'm going to leave them because it's actually part of the formula here. So recall that the area of a triangle is base times height divided by 2, right? Because if you take a quadrilateral and you cut it in half diagonally, you get 2 triangles. Okay, so it's essentially this, but it gets divided by 2. It gets cut in half. So 5 times 12 divided by 2 times the height, which is 11. And just like before, 3 of these are going to fit into a corresponding a base with a shape that has two congruent bases, okay? So slightly different formula. Really the only difference is that these two, after you multiply them together, gets divided by 2. Okay, that's going to be pretty much it for today. If you have any questions, you guys can see me on Zoom tomorrow at 11. Okay, take care. Bye-bye.